Test.
So welcome everyone. We are Deeptector, and we have developed an innovative solution for fighting deepfakes. With our solution, we use AI to fight AI, since this is very much an artificial intelligence issue. We have developed a website that you can simply drag and drop an image or video, and it will make a prediction.
Hi, my name is Imad, and I'm a graduate student here at Mizzou.
I'm Colton. I'm also a graduate student here at Mizzou.
My name's Ashlyn. I'm a senior studying data journalism here at the J School.
And I am Caleb. I am a PhD student here at Mizzou. And one thing really unique about our team is that there's 3 computer vision experts. All 3 of us are in the computer vision lab here at Mizzou. And we're all very smart when it comes to the research. Don't mean to brag, but we are also have a unique contribution to the team. Imad here is very good at graphic design. He helped create these great slides, very impressive work. Colton here is very good at the web development side. Ashlyn here has helped give us a journalism perspective, which none of us really have, seeing as we're computer science research students. And I have a little bit more entrepreneurial experience, so I was able to help think about maybe from a business end.
Okay, so this competition is obviously hosted by the Reynolds Journalism Institute. It is, though a technical challenge, it's very much rooted in what the field of journalism needs as society becomes, more increasingly digital. So as you are all now pretty familiar with what deepfakes are, but they involve the intentional manipulation of media, whether that is video, images, audio, to deceive an audience, whether that be, that could be a whole range of things. And when we talk about, journalism again, we talk about what is the expectation of journalists, or what is their role in society. They are, at a very basic level, their job is to check information and to share authentic information and to make people smarter, make their audiences smarter. And as I mentioned, the world is becoming increasingly digital, and it is expected that journalists kind of embrace this transition into, a digital realm, and to subject digital information to the same scrutiny and hold it to the same standards as they would any other type of information. So this video, which we have now seen a couple of times, and that was also given to us by RJI here to run through our app. This is a video of President Obama, or then President Obama, and this kind of highlights that even though, there is a humorous nature to deepfakes, and, it's one of those things you can share with, like, friends and family, the threat that they pose to democracy and to the trust relationship that exists between constituents and their elected representatives, and kind of mirrors the trust relationship that exists between readers and the journalists they follow or the news outlets they subscribe to. And this potential to introduce misinformation or to disseminate misinformation does pose a legitimate threat to that relationship, and it's something that that should concern journalists as much as it concerns people who subject or consume misinformation. And another thing that's important to keep in mind is that, it's 2020, we're heading into an election year. The trust relationship with constituents and elected officials is already being tested with everything from the mishap of the Iowa caucuses to interference in elections. It's already something that people are thinking about, and it's already something that journalists are going to be expected to respond to as kind of I want to say gatekeepers, but people look to them to provide accurate information. So this is an issue, my point is this is an issue that's going to be coming up again, and that I would expect, or people expect, to play a big role in the 2020 elections at the federal and state level. This is another example of kind of the expectation that's being put on journalists in 2020 and just the 21st century generally. This is video footage from last month of the Boeing 737 that was shot down in Iran. Almost immediately after the plane crashed, there was cell phone video circulating on Twitter that people were sharing, even though it had not been verified and people didn't really know where it came from. It looked to be what they thought it was, so they were sharing it anyways. And the New York Times kind of took it upon themselves to investigate just this video, and it took them a couple of hours, I want to say maybe a day, a couple hours a day, to release this article, which kind of detailed the steps they took to go through and verify this. And then they were able to kind of verify their own verification with security camera footage that they got later on. So even though this is not a deep fake, it does show that media outlets are already responding to this kind of citizen journalism, as it's sometimes called, where people are sharing videos and they're kind of gaining momentum even though they haven't been verified. So this is something that reporters and news outlets are already having to deal with, but they're having to do it in a way that's not necessarily effective or very time consuming, which leads into the app that our team, or my team, has created here. And the idea behind this is that it's supposed to be simple, it's supposed to be accessible, it's supposed to be easy for journalists to use on deadline so that we're not kind of waiting for something like this, days or hours, however long it takes. But it's something that, we can respond to in a more timely manner. And with that, I will hand it over to Colton to talk more about the specifics of the app.
So yeah, so our solution, as Ashlyn said, is deeptech.io. It's a web app, and it's designed, we've really optimized it to be easy for journalists to use. So that's been kind of our goal throughout this whole process. So we've designed it to be really easy and accessible. Obviously we want it to be accurate. And we've designed sort of the architecture of our whole project in a way that as deepfakes evolve, we can evolve with them. So this is just the sort of 30,000 feet view of how it works. Really all the user has to do is upload a file. There's some artificial intelligence models that run it in the back end, and then it puts up a prediction that's really easy to parse and kind of absorb. We'd like to do a brief little demo. Oop. If I can. Sorry, I'm not a Mac guy. Are we?
Come over here.
My bad.
There it is.
Okay, there we go. So this is our web app. Like I said, we've designed this to be really easy to use, so you can actually drag and drop a file into this box here and it'll run. I'm going to go ahead and click to upload to avoid any more fun. So here's one of the images that we were given. So all I have to do is just click open, and it's going to start to process. Right now our processing times are a little long. We're, as with the last team, hosting our web app on a fairly weak server at the moment. It's got a kind of a weak CPU and not a lot of RAM. So, I mean, with images it's fairly fast, but with videos it takes a minute at the moment. But we have actually done some tests on some more capable machines, and we can get our processing times down to about something under 2 seconds per video, as long as we have a GPU. So, in the interest of, sort of transparency and making sure everyone knows how this works, we've also got an about page that just kind of explains how everything works, and also talks about user data. So in our case, we don't save any of the user's raw data. So if a user uploads a video, we process it and then it's gone. And that allows for the privacy and security of our users and also keeps our storage costs a little lower. And another thing that we implemented that we'd really like to show off is processing of YouTube links. So we can actually, here we go. If we come over here, we can grab a YouTube link, and we can actually just plug that in to our web app directly, and that'll go ahead and process. And we've actually implemented a small database on the back end so that when someone submits a link, the link is saved so that if we make a prediction, we don't have to make predictions on links twice, because a YouTube link is going to be static enough that it's easy to save. Yeah. So I am going to pass it back off to Ahmad to talk a little bit about how the kind of deep learning technology works on the back end.
All right. So, oh wait.
Yeah, you got it.
There we go.
not a Mac person either. For the development of this project, we used a deep learning library that is open source. It's called PyTorch, and we trained our AI on a GPU-enabled server infrastructure, and then we created a supporting web application using a Flask that ran on Docker container, and then we deployed that into an Azure cloud infrastructure. The reason why we chose Azure cloud infrastructure is its scalability. So as we get more content or more videos or more demand on our website, the application will be able to automatically scale and give the users the functionality that they need. So one of the first problems that we had is obviously face tracking. Our algorithm provides a very reliable and robust face tracking without sacrificing on speed. The reason why we thought this step is so important is because it helps our AI focus its attention only on the face features rather than the whole video. Therefore, it reduces the computational cost, and it also gives a much better accuracy. So for the AI of this project, we use what we call a deep learning model. And what this means is we have a model that trains on real-life data. This means that we can input a ton of data into the model, and it will automatically learn from the data to say whether it's fake or not. The infrastructure that we used is composed of mainly two parts, a convolutional neural network, and this simulates sort of the human vision. And what this means is it looks at every frame of the picture, and then it converts all the useful information in that frame into what we call a feature vector. And what a feature vector is just a summary of that image. And then we feed that feature vector sequence into a long short-term memory neural network, or an LSTM for short. And what this does, it processes the temporal information, because we think that deepfake videos has also like temporal cues in them rather than analyzing frame per frame basis. Finally, it produces an output of whether or not the video is deepfake or not. So to evaluate our model, we collected a small data set of 300 real videos and 300 deepfake videos. We trained on 85% of the whole data set, and then we tested on 15%, and we got a great accuracy of 97%, which is very promising when we finally train on a much larger data set. I assume we're talking about the Facebook Deepfake Detection Challenge data set, just like Fake Lab. And I'll hand it to Caleb to talk about the business plan.
Hello? Can you guys hear me? Cool. So we did a little bit of research as far as the commercialization aspect of everything goes. And so we wanted to just go ahead and tell you guys what we found out, just to get a start as far as maybe turning this into the business. So first off, we investigated the need. We wanted to make sure that there really was a need for this project and make sure that we were really actually hitting that need. So we learned that there was a significant increase as far as the number of deepfakes online since 2017. Now there are over 14,000 deepfakes online, which is a good amount, enough to be a major concern, and it's exponentially increasing. So the number of deepfakes online is only going to get more. We also learned that the technology to use to create deepfakes has also exponentially increased. So in early 2016, there were hardly any papers published using that technology, and now there are significantly more. We also learned that some major players are investing in solving deepfakes. Facebook is a big one. They invested $10 million, and Amazon's another big one. They invested $1 million. So this tells us that there is a huge need to find a solution for fighting deepfakes. So early on throughout our process, we did a little bit of investigating as far as who would our target customer be. Obviously, this is with RJI, so we knew that there was probably a customer segment in media and newsrooms and that sort of thing. But we also thought maybe the average person might be a good customer. So, so we learned here, we have a little bit of feedback here. and we learned that while some people were interested, that might not be the prime customer. So we went on to start looking at the media, and we learned that for the top 10 media companies, there was an $820 billion market cap. Some of these companies are pretty big, and we all know them. So that tells us that there's a huge market in media and newsrooms. So here we did a little bit of investigating on the stakeholders. Who might the major players be? We talked about the main customer, media and newsroom. Media consumers, everyone wants to trust the information they get. Public figures, they want to protect their reputation and careers, and so they don't want false media about them. We also learned that governments and organizations might be another major player. You could sabotage another organization, or there could even be propaganda against the government. So this is something very important that we think that is a major problem that we could address. So this might be familiar to some people. This is a business model canvas. It's basically a good starting point and launching point for business. And so we did a little bit of investigating on our different customer segments. We talked about the media and newsrooms. And then we also did a little bit of investigating on the value propositions for them. So we know that we could offer them a higher accuracy. We know that we could give them faster results, and we know we can give them more confidence in their results. We also investigated what sort of revenue stream could we make from this. So we thought that the best sort of revenue stream might be a subscription service, and it would allow for bigger companies, like the big media companies we listed, to pay more, but also for smaller newsrooms to pay based off of their viewers. We did a little bit of investigating in the competition. So we learned that there were 3 solutions right now that were basically pretty similar. Those are TruePic, Searlay, and Amber, and they basically offer an app for your phone where you can record a video from the ground up. They have control of the entire process, so you would record the video within the app, and the video would never leave the app, so they can basically guarantee with 100% accuracy that the video is real. Obviously, this isn't the most ideal circumstance. Not everyone's going to want to open an app to record a video. They're sending it to newsrooms. That's not going to be ideal. So this solution isn't the best solution. Manual analysis, which is where we're at right now, is where if a company gets a video, they would do some background research. They might look through the video. Does it look real? And then they do some background research like we talked about earlier with Boeing. Is that video real? There's also a solution called Deep Trace, which we found it's probably the closest solution to ours. They offer tools for developers where you can go on and develop your own tools for fighting deepfakes. We don't think this is the most convenient solution for big companies or even small companies to do. So we have developed ours with the idea of creating it as easy as possible. So we did a little bit of research as far as product name goes. We asked some people, what product names do you like? And we learned that by a large margin, ours was preferred. We got a little bit of feedback on design. For the most part, people liked the design of our website. They thought it was easy to use. But ease of use was the lowest. So after we got this feedback, we took steps to improve. That's when we created the YouTube link feature where you can submit YouTube links to make it even easier for the user. So now I'm going to talk a little bit about our vision for the future and what we want to do. So we want to make it even easier to use. Right now we think it's pretty easy, but we have some ideas for improving it, such as an extension for the browser that could easily let you verify video. We also want to make it more accurate. Right now it's pretty accurate, but we want to train on more data, more diverse data, so that way we can make it even more accurate. We also want to scale up for large organizations. We want to have a bigger servers. We want to have a login system for authentication and for large organizations so they can manage their users. We also have some business goals too. The first thing we want to do is we want to really get in there and talk to the companies. We want to talk to newsrooms. We want to talk to media companies. So that way we can really learn what is their actual need and how can we meet those needs. We also want to improve based off all that feedback we receive. And then lastly, we want to try to find investors. That way we can really scale up our product. So thank you. This is our presentation. We had a QR code right here, so if anyone wanted to test the website, they can open their phone, go on the camera, and open the QR code. If everyone tries to test for a deepfake at once, it's not scaled up to handle everybody at once, but if one person, a few people want to try it, you can go ahead and look around on the website. So thank you.
Is there a processing difference between uploaded videos and videos with a link?
Let me answer that. Do you mean if there is a different pipelines for videos versus audio, versus images?
I'm sorry?
Is that your question is whether we process them differently?
In terms of time length, if one inserts a link or if one uploads a video, I'm assuming there's
Oh, so
an option for both photo and
the link and the video takes about the same amount of time. That's because we download the video into our server first to test it, and then we delete it. So it's around the same amount of time for links versus uploading a video.
We do have a small database of links on the back end, like I mentioned, so that if a link has been submitted previously, say there's a really viral video, if we have the link and we made a prediction and we know it's the same, then we just return the same prediction.
Yeah, and that's usually instant.
thanks.
Hello? Hi, can you hear me? I had a question about the data that you trained your model on. You mentioned you had collected 320 real and 320 fake. That seems like a pretty small number of videos to train on. And I'm also wondering about how you created that sample and any biases that might be present in that sample that would limit the scope of applicability of the model that you've trained.
So the data set that we used is called a TIMIT or deepfake TIMIT. We used actually both of them to get the real videos and the fake videos. The reason why we had a small data set is we just wanted to have a preliminary stage of validation. Like we wanted to know whether our model is suitable for this task. The video data set that we had was small and simple, but it gives us an idea of how it would perform when we train it on a larger data set. We recently got our hands on the Facebook Deepfake Detection Challenge dataset, which is, as he said, like 500,000 videos. And we currently don't have the computational infrastructure to train the model, but we expect to have a good accuracy on that dataset as well. And our model will be more robust to all the videos.
And we did test a little bit off a subsample from that dataset, and we did achieve fairly decent accuracy just off a tiny subset.
Yeah, a subset of the
Facebook dataset.
Can you say more about the accuracy and
I believe that we got up to a little over an 80% accuracy on a very tiny portion of that data set. So if we were to train on even more, we believe that it would go even higher.
I'm going to ask a similar question to the last one. Does the success of the model that detects the fake video require manual feeding of fake videos to your system, or is it just automatically done?
So it's automatically trained on the back end, so it's already trained right now. We also implemented a little feature which isn't, it's more just for demonstration, but we could theoretically learn as we go. So we could continuously add data automatically like you're speaking of.
So one idea for that would be when the user uploads a video, we don't save the video, but we can save the features extracted from the video in our database. And if the user was satisfied with the accuracy of our results, we can then use that data to further train our model on the go. And this is also an offline process, so it doesn't cause the user to have any delays when they submit a video.
Is that ready now, or is that something that is going to be down the road?
That is ready offline, but we have not deployed that feature yet.
Storing the features extracted from the video is way worse than storing the actual video on your backend.
The
from
features.
a privacy perspective.
Is that a question or
That's
just
a comment on your?
I think
answer.
the videos, the way it's just what you're saying is maybe password storing is also bad. when we upload a video and convert that into features, it's the same as password hashing. What this means is we cannot go back from the feature we cannot recover from the video from the features themselves.
And
At least with our convolutional neural network, because it's not an encoder-decoder type of situation, it's just an encoder. So when we have the features from a video, we will not be able to go back to the video itself.
And furthermore, I would add that that is a privacy issue, and that's something that we would give the users an option to do. We wouldn't just take the video and say, okay, we're going to have your features no matter what. It would be something that if they wanted to help contribute, just like if you have a Google Home, you say, oh yeah, I want to help, you guys can have my data so that you can improve your product. And it would be the same thing. We would allow them the option to improve our product if they would like to.
Except that we'll make it clear that we do not store their raw videos. Yeah. And we have no option to restore their videos anyway.
So kind of echoing off of the last train of thought, with the storing of data, do you have anything already developed for the end user as far as like being able to control or opt out later, or be aware of the data that they've contributed? And I'm just thinking of things like with the European Union's recent, as far as like just cookie data goes. So, I mean, this is obviously more extensive than that, but has your team put any thought into that? And
of course, yeah, and that's something that we, I mean, currently the website that you just saw, we think of that as a prototype. And when we have a tool for final users, we will make it clear what happens to their data, and we can even consult with some lawyers.
And even going off that, we have what we showed you on the website. It shows an option. It says, would you like to contribute every time you submit the video? So it's not like we're just actively collecting data. Right now, we're not even collecting any data. But what would happen is we would ask them every time, say, would you like to help? And if they don't want to, no. And then it goes away.
One more quick extensibility question. I love that you integrated the YouTube functionality. Have you thought about some of the other major providers of video, so like Facebook video and Twitter video?
Yeah, so those are definitely one of the next steps as far as ease of use goes. YouTube was a good first step to show you that we could do it. Twitter was another big one we talked about. Facebook would be another great one. And really just any sort of video you could find online. Our goal would be to just be able to get a link and then put it in there and it will automatically do it.
As long as it's publicly accessible.
Right.
So I did have a clarification question. So in the last team, there were some questions around how that percentage rate was calculated. Could you expand on, what's the algorithm that you're using to come up with that percentage rate for videos? Is it based on the number of frames that the model thinks are fake, or is it an overall calculation for the entire video?
Yeah. So actually, what we do is we we have one prediction per video, and the videos are about 4 seconds, so they're not very large. And to augment that, we split them into 1 second chunks, and every second is evaluated separately, and then based on the seconds or the seconds that were classified correctly versus incorrectly, that was the number. That's where we got the accuracy number from. Does that make sense?
So you're classifying each second of video as deepfake or not, or as fake or not fake.
So if we, in my example, if we had like 100 seconds, 97% of them were classified correctly, then our accuracy is 97%.
And I think a key difference for our model for videos is that we trained it specifically for videos. So it uses the time within videos to help improve its accuracy. So it should theoretically be pretty accurate on videos because it's a model trained from the ground up on videos.
Yeah, I think this is a really key conceptual issue that needs to be communicated to end users. In general, for this project and the last one. I don't know that it's intuitive that you would think that 97% means that 97 seconds out of 100 were classified as fake. And three
so for
seconds
the-
were classified as true.
Sorry about that. For the prediction that we give to the user, that's different. That we give them a percentage of how likely this video contains even 1 second of deepfake.
I see. So okay.
And
All
then
right.
whatever the
That's a different thing
confidence,
entirely then.
yeah,
So,
and
yeah.
whatever the confidence level. I thought you were asking about the training accuracy, which is something different.
Okay.
But what we give them back, just to reiterate, we give them back the probability or how confident our model is that there is at least 1 second of fake videos on the or fake content in the video. Did that answer your question?
Yes, that's what I was asking about. Thanks.
And probably this similar question regarding photos. How is that displayed in terms of the percentage?
It's the percentage is just simply how confident it is that it's a deepfake.
Of what percentage is manipulated?
Not what percentage is manipulated, just how confident our model is that it's a deepfake or not a deepfake.
So if it's at 50%, it would be unsure of if it's real or fake.
Mm-hmm.
It does not specify on a photo like what portion.
Parts? Oh, no.
Usually in these videos, it would probably be the face that's fake. So we did highlight that, but
Yeah.
it does not
Yes.
say what part.
The only checking that we do is we look at the faces only.
Right.
And again, this is very hypothetical and may not be like a practical example, but it doesn't look at whether the audio is fake, right?
No.
Okay.
Currently, it doesn't.
As of right
We're working on an audio model separately.
We actually trained an audio model on the back end to see if we could do that. And we learned that it's something that we definitely could implement. It just wasn't in the deployment phase.
Right.
Mm-hmm.
All right, thank you so much.
Thank you.
All right, deepfake, you're up.
I think this might be dying. I don't know if it was working while I was up there. I kept turning it off and back on.